Okay, this is the P3 paper from January 2023. It's question number 3, and it's an exponentials and logs question, and in particular, the logs and nonlinear data question. Let's have a look at it then. So it says the line L in figure 1 shows a relationship between log 10y and x. So just have a look here. We can see this isn't y against x, this is log 10y against x. Passes through those 2 points, and it says, can we write down an equation for L? So yeah, hopefully you've done a few of these. This is a relatively new topic. Hopefully you've looked at some other questions that are similar to this one. What we can basically say is if we look at that graph here, we can say this is a straight line here, and if it's a straight line, then I can say y equals mx plus c, but just being aware that y later on is going to be replaced by log 10y. The x can stay the same, but what I need to do then is to work out m and c. Well, c is easy because it's right there straight away. C is going to be 1.5, but let's start off by working out the gradient. So the gradient, which is equal to m, if we've got those 2 points there, is y2 minus y1 over x2 minus x1. So that's going to work out to be 1.5 minus 0 all over 0 minus 4.8. In fact, I can write minus 4.8 there if you want. That's 1.5 over 4.8, and that works out to be, I'm going to leave as a fraction, 5 over 16. Now we know C already is given by 1.5. So if I was writing these, then y equals mx plus c is going to be log 10y is equal to mx, which is 5 over 16x plus c, plus my 1.5. This is plotting this one against this one, with c being here and m being the gradient that we just found. So that straight away is the equation for L. So not too bad with that first part. Part B then says, hence or otherwise express y in the form kb to the x, and give all the values of the constants and everything for that. So again, as I said earlier on, you need to have practiced doing these questions already, because I know exactly how to get started with this question, simply because I've seen one similar to it. If we've got y equals kb to the x, what we can do is apply lots of different log rules to this. So first of all, I'm going to take log of everything, and I'm going to take log to base 10, because I know that's in the question there. So I'm going to say log to the base 10 of y would be log to the base 10 of kb to the x. And so now it's this side, and I'm going to say, remembering that log of ab is log of a plus log of b. Well, I'm going to use that idea. Let's just get rid of it. I don't need to write that down, but that's going to give me nothing on the left hand side. We'll just leave that as it is, log 10y. But here I can now break this up into log 10k and log 10b to the x. That's a product there, so I've split it up into the 2 component parts. And then here, another log rule means I'm going to be able to take that x down, which is the next thing that I'm going to do. I'm going to say log 10y is equal to log 10k plus x log 10b here. And now what I can do is pretty much make a direct comparison between that and what I had previously. So I had log 10y is equal to 5 over 16x plus 1.5. So here we've not got these quite the right way around, but that's no problem. We can just rewrite that then as being log 10y equals log 10b all multiplied by x plus log 10k. What I'm doing with this thing is just swapping those over, and I'm actually just writing the log 10 on that side there, so I can make some direct comparisons now that if I'm looking at these, I can say, what have I multiplied by x here must be the same as that one, and what's my constant here must be the same as that one, and then I'll be able to get some equations I can solve here. So if we look at the coefficient of x, I'm going to get log 10b equals 5 over 16. Now you need to be able to do this where we've got log a to the b equals c, something like that. What I need to do is be able to change that log statement into a power statement. When we're doing this, we remember the base of this is the same as the base of my power statement, and we say that, or hopefully you remember that, a logarithm is a power. So if a logarithm is a power, then that thing's a power. I'm going to change that to a to the c equals b. Well, we basically do the same to the left-hand side here, and we can say, okay, then 10 to the 5 over 16 is equal to b. So that means I can work out what b is. B will work out to be 2.05. Let's get rid of that bit because that was just my explanation. For you guys, just go back, and it does say about, 3 significant figures. So I found the value of b to 3 significant figures following pretty much the same thing. Do you know, I'm actually going to put it next to it. I normally tell students to write it underneath it, but here, excuse me, I can also say at the same stage that log 10k is 1.5, this bit and this bit are the same as each other. And so following exactly the same logic through, then 10 to the power of 1.5 is equal to k, so k works out to be, to 3 significant figures, 31.6, which means that we've answered both parts to that. And this start off point here, you should have done enough times to see that this little bit just down here is very, very standard and comes up in pretty much all of these nonlinear data questions. So hopefully that all makes sense.